Hi guys. So I was trolling to Seed Studios website and I noticed this starter kit. And for a while now I've been wanting to look into this Grove infrastructure that they have with these different modules and so on. And I was wondering if one of those little starter kits could actually make it easier to develop some projects. And I think it does, but there's some caveats with this little board, and I found that when I first started, I just plugged it in and tried it out, that in actual fact at best half of the example programs actually worked with the I was using ESP32S3 board, Xiao board that I plugged into it. So I started to do some research into it and found out what was going on, and I thought there was a sufficient information there to actually create some videos on, which will be helpful for people that want to get into this microcontroller stuff and use maybe those Grove modules to make it easier. And I decided to do a series on that of different episodes. Each episode will deal with one of those little different modules that come with that kit. And so I will have different episodes in that. Also, I want to discuss the differences between Arduino IDE and Platform IO and all that kind of stuff. So make sure that you subscribe and like and get the little notification bell thing going so that you'll know when new videos will come. Of course, the description will have information in it about that also, and links to the various websites and GitHub sites. I'll put my code on GitHub as well for this particular series. So this is what the kit is. Now I have received it, and next we will have a look at it, what's in there. We'll do a little unboxing of the thing and see what's there. So let's open it up and have a look. There's a sleeve on there that can come off. There's over here that it has a Xiao expansion board, a Grove LED pack, a Grove light sensor, a Grove servo, and a Grove LED, RGB LED strip, and a Grove infrared receiver, and a mini per motion sensor, and 7 Grove cables. And it's got a temperature and humidity sensor, rotary angle sensor, and a 3-axis digital accelerometer, 20 key mini controller, and a male jumper wire, and a Type-C USB cable. I thought this was a convenient way to buy a bunch of stuff and getting the little boards and things with it. And okay, this is a little remote control. Must have a battery in it, and you pull the tag there, I guess. That must be for the RGB lights and some other things perhaps. And let's have a look. This looks like an RGB light strip. Yep, that's what it is. We'll try those things out. This is a little servo motor kit. I'll leave it in the bag. It's got some little screws and things there. Typical useless little USB cable, kind of short. Couple of LEDs. These are the little so-called Grove cables. Nothing special about those. They are just rubber band off. They are just 4-pin to 4-pin connectors of a common type, and a couple of DuPont little DuPont wires. I will add that to my supply. I got a whole box of these things. And let's have a look. You see, so you have these modules, they have these connectors on there that you can actually, it goes like that, yeah. And you can just plug in these little cables and then plug those cables into the board. This is a rotary encoder thing, I would presume. Humidity and temperature sensor. There's an LED socket kit. Looks like you would take these LEDs over here and plug them into that little socket there, and you can probably adjust the brightness or something with that. Pretty rudimentary stuff. This is an IR receiver, and this probably is a light sensor. This would be a good kit for some people to get started. This is a 3-axis accelerometer. And here we have a mini motion detector. This little board over here, let's move some stuff out of the way for clarity here, will house one of these Xiao modules. Now, I've got one here that has soldered pins on. They don't come with little headers anymore nowadays, but I've got a million of those things laying around. And you would plug that in. This particular one is a, let me see now, it's an S3 or C3, I can't. This is an S3. This is one of the S3 modules. And it has on there a little OLED display, I think LED display, and these are the sockets that you connect those Grove things to, and I presume that this here is for power, and it looks like on the bottom here there is a way to put a little battery in there. Which makes one wonder if it's got a real-time clock chip on there somewhere. And it looks like it has a little microphone. No, that's a buzzer. A reset button is on and off. Well, I must presume that this is a just for power, I guess. Okay, so the contents of that starter kit is pretty much splayed out here on my desk, and plus a few extra items that we're going to be trying, which have nothing to do with the starter kit. We've got some third-party modules here, RFID2. We've got a stamp C3 just to prove that this Grove system works across different microcontrollers and different companies. So we have the original cables here. I made up a few little extra cables here for different with DuPont pins on them and so on, to plug into different things to try out as well, which we'll get to in the individual episodes. I'm going to do different episodes for each one of these modules over here because I found out different things about them. This is the little expansion board. I actually put a little battery on there, which I found in my junk box from an old flip phone. Made up a little piece of sheet metal here and some little piece of wood, some junk stuff, a couple of pogo pins that connects the battery, so I didn't have to solder leads to it. They're exactly the same as those pogo pins over here that actually connected these Xiao modules. All of these Xiao modules have little pads underneath, as you can see, but connects with those. Some have more than others for different purposes, but the first four, like this one here, only has 4 to start with. That's the original SAMD module, and this one too also has 4. And this allows that reset button to work and so on, because it comes through there and what have you. Okay, so these are the Grove connectors. We'll have a look at that in a second on the online description. Comes with a switch to switch the battery in and out. This is the battery socket. You can actually buy batteries online that already has that right kind of socket on there. You wouldn't have to do what I did to try to repurpose an old battery for something else. You'll plug directly in there. For Grove sockets, now these Grove sockets can vary according to what their purpose is. Some of these, like this one here, only has 3 pins connected, and it just connects to the D0 pin, which is this one over here, and this one here connects to the pin 6 and 7, which are those 2 over there, which are actually marked to be for receive and transmit. That's why it's marked as UART. You won't see that right now, but you'll see it when I use the overhead camera to enlarge it. There is a real-time clock chip over here that can keep the time and date. There's a little buzzer over here, teeny weeny one, and a user button. So we have 4 different Xiao modules we can try in the different episodes that are coming up. There is an original SAMD21 or SAM21D, or whatever they call it. SAMD21. There is an RP2050 Raspberry Pi microcontroller version. There is a ESP32C3, and then this is actually an S3. There's an ESP32C3 as well. So I've got those 4. So this is what they point you to at the Seed Studio website to support this actual expansion board. And there are some links over here. They have updated it slightly in recent times. They have a it says now it works with the SAMD21, which is your original controller that they released like over 10 years ago, I think. And it supposedly now supports RP2040, those are NRF things, ESP32C3 and the S3. But there are actually more controllers available now, which is what you can see if you go to over here. There is the original SAMD21, which is basically what it was aimed at before. These are the NRF 52840 based boards, and they are ultra low power, good for battery powered projects. I don't have any of those. Might get one in the future to try out. I have the RP2040. There is a newer version that's been released recently in RP2350. It actually has 2 different cores in there that you can select in your software. That's something that I haven't got and I need to look into in future as well. This is the C3. We have that. We got the S3. Don't have the C6, and this one here is also something I actually wasn't familiar with. 32-bit ARM Cortex MCU. I must try that out and get one of those in the future as well. But as I said, they did update a little pieces for some of those, like the C3 and so on, as you will see, but they didn't consistently update everything. So some of those examples in here will not work unless you are in the know and you know how to change the pin numbers and stuff like that. Any case, As you can see, battery switch. It has two I2C Grove sockets, OLED display, real-time click, clock, chip. This SWD port that is specifically aimed at if you got an ARM type microcontroller that's used for debugging. I haven't tried that. I tend to do my debugging using ESP32S3 chips, and then you use a JTAG debugger, which actually goes right to the USB port, but that's what that is supposed to be. This socket over here, I don't think it is mentioned in the actual text below when they are dealing with the servo, but this is actually really where you should connect that servo module to, because it is 5 volts and not 3.3 volts. And my experience was originally it came with a growth socket, so I just plugged it into one of these sockets over here. And interestingly, when I used the ESP32S3 chip, it just didn't work. But when I plugged in the ESP32C3 chip, it did start working, but obviously the 3.3 volts that is supplied in those sockets is not enough for that thing, and there was maybe just a slight difference in the voltage that it supplies for the two different chips, but it barely started working on the C3 one. But really, this is where you have to connect your servo to, which is kind of strange because they put a growth socket on there, and it is not completely compatible with this board. In any case, when we get to that thing, we'll discuss that in detail. I made up an adapter for it. What else is there? User button, reset button, has a buzzer, and these two sockets, these growth sockets, actually vary according to different use cases. This particular one here, for instance, has only 3 pins connected, and the fourth pin that's connected to A0, D0, which is the same pin. UART is pin 6 and 7. That's kind of if you need serial input or output, I guess. You can use that one. And these two here are connected to the same pins on the chip there for I2C. At the bottom there is a micro SD card slot, and there's a little socket here that you can put a button cell in for the real-time clock. But the way I've coded the real-time clock test code, we don't used to use that. And in fact, I can't even find a button cell that fits that thing in my collection somehow. Okay, so this is then the pinout and the usage of the various pins. They've got different colors here. This is the standard pinout, you know, for the that you will find on all the Xiao modules, but more or less. There's analog usage, and on ESP32 chips specifically, all the pins can be either analog or digital. And so if you're going to target an analog pin, you would use A0 to A10 or something of that nature. If you are going to, which means that you're going to do an analog read on it. If you do digital read and write, then you would use D0 to D10 to signify that. The I2C is actually SDA and SCL, and UART is over here. So basically what that means is that there's a growth connector here that has pin 0, GPIO 0, that's this one here. There is a user button, which is over here, which is actually connected to GPIO 1, and you would specify that as being D1. There is 4 pins actually connected to the micro SD card, and that uses the SPI bus, pin 2, 8, 9, and 10. And A3 is connected to that buzzer, and the I2C, both of those I2C sockets are connected to pin 4 and 5, GPIO 4 and 5, and they are well, they are used when you need IC or I2C modules. UART is connected to this socket over here, which are pin 6 and 7. Obviously, you can actually use those pins as A7 and D7 as well, so it doesn't specifically has to be used as a UART socket, but that is wired in case you need that. There are, as I said, there's an SWD thing here for debugging, which we won't get into in this series because we don't need to. Reset button is over here, and it connects to those little pins at the bottom over here, ground and reset. Connect that button over here, those pogo pins. And I think that's all that there is to say about it. Then it goes on over here, to talk about, shows you that original SAMD thing, Xiao module that you plug into over here. And it seems to be a different kind of board that they've got over here because there's a real-time clock chip underneath. And the newer ones, and the button is at the top rather than on the side. So I don't know, but there must have been an earlier version of that. Then they go and discuss a whole bunch of stuff about how to program in the C# and the Arduino IDE, which we won't get into either. You can certainly, if you're a beginner, you can certainly read about that. That will be good. Then if you look at the actual little projects in there, here for instance is how to use the buzzer, and there will be code there discussing how that is used. And like for instance, the code is over here for that buzzer, and you would actually copy that to the clipboard, and then you can run it. And if you do, you'll hear absolutely nothing, because I have found out that little buzzer on there only works at certain frequencies, around I think 3000 hertz or something. And when you run it at 200 hertz, you don't hear nothing. Maybe the early boards had a different kind of buzzer on there. I am not sure. But again, that is why I did this series here, so we can actually discuss that and have some more extravagant, detailed code that actually uses these things properly. Another thing that you will find is that some of the libraries that they refer to are actually now embedded in the Arduino IDE, but some of the newer ones don't work, and you have to download the libraries from their GitHub site. So all those things we can discuss and make it work. So that will be helpful if you're just getting started with this stuff. Okay, so I plugged in the ESP32C3 module. We will select one of these little Grove cables, plug it into the module. We are going to be using this port over here, and remember, let me plug this out so you can see it actually. You see what it says over here, A0D0, and it's got a ground, 3.3 volts, and no connection on the third pin, and 0, as it says over there, on the outside pin, which is exactly what we need for this LED, because it also has signal, no connection, VCC, and ground. So that matches exactly this little socket over here. Now, I could have plugged this one into here as well, or even those two. It would have just worked just as well. But this socket is more aimed at this kind of module that only has 3 wires, and we don't have to use we can leave the other ones open for other purposes. Okay, so this is ready to go, but now we got to go to the software, and we will use the Arduino IDE for now. As I said, in the next project episode, we will be discussing the platform I/O system. Okay, play capture. So we have a very simple little program over here. I don't know why they call these things sketches, but we also seems to have some problem with the M5 stack thing, but never mind. It still seems to work, but we're not going to be using the M5. We got the C3 plugged in. I'm going to plug it into the computer now. Plugged in the USB cord. Okay, so as soon as I plugged it in, it realized that we have a ESP32C3 on COM5. So we are cool with that. And we have an LED connected on D0. Remember that the socket that we plugged it into has D0. The actual button, as you saw on the description earlier, it's actually on D1. We have a little integer here, button state defaults to 0, and setup simply sets the pin modes, output for the LED, input with a pull up for the button. That means that it's high unless the button is pushed in, it will be low. And we turn the LED off by default. We don't want it to be on, and until we turn it on. So we do a digital read on the button, and that is stored in that button state integer over here. And if the button state is low, in other words the button is pushed in, then we turn the LED on high, so it is on. Otherwise the LED is going to be set to low, so it'll be off. So if the button is on, it'll turn it back off again. We have a little delay here. It's always a good idea, just in case some of those microcontrollers need a little bit of time for stuff to settle down or something like that. Totally optional. I could have left it out for the ESP32C3 and it would have worked just as well. Anyway, so it is plugged in, it's ready to go. So I have already done a verify that it compiles. So we should be able to click the upload. Does it compiling, connects to COM port 5. It is uploading the code. And so now we should be able to go to the camera over here. So this is our module. The LED is plugged in there. Push the button in, and sure enough, the LED comes on and goes back off again. So that was a simple little test. Everything is working. Now I'm going to unplug this. I'm going to unplug that. And the one thing you got to realize is that this expansion board over here, there's nothing magic about it. What is good about it is that you can just plug your module into there. You don't need a breadboard, and it has onboard an OLED display. It has, of course, these growth sockets which connects to the pins on the thing there, which also, of course, it's like I've made up some, as I said, some little cables over here. I can easily plug those into the pins directly here and have an output as well. And as I indicated earlier with that servo module, I actually was able to, there's a 5-volt output on this pin over here, and I was able to feed the servo at 5 volts and still connect it to the 2 pins that I was using to connect the servo with, and that made it work. So you don't really need this board, but then you'd have to buy these components: a little OLED display, a real-time clock, a button, and a buzzer that's on there. You'd have to buy those separately and make up some leads for it. Here, for instance, during testing, I have a little buzzer over here that actually just has got 2 leads. I can plug them in, and that would do the same thing as that buzzer over there. Of course, this is bigger, it'll be a bit louder. So there's nothing magic there, but this is very convenient to actually develop your software and to do some testing. That's all. But to demonstrate that, that you can use other modules and microcontrollers. As I said, this particular one here has the ability to also have a Grove modules plugged into it. It actually, you know, the pins, it actually, this module, this socket actually uses the like 4 pins that are over here, and the other 4 pins are over there. They're wired up like that, and at the bottom there you can actually see the ground 5 volts, G1, G0, ground 5 volts, 19 and 18. That is what these sockets have on them. I've plugged it into the D0 one, or the G0 one. So let's plug this thing in. There we go, and let's have a look at the code over here, show you how simple it is to change it. For a start, we now have a different board, and it has recognized it already. That's an M5 stamp C3 on COM8. Yep, that's what we will select. Now these pin numbers are different. They just have numerical values. It's similar to an Arduino. So LED is going to be on pin 0. Because remember it said G0, but that is GPIO 0. And this one over here actually it's got a built-in button that's going to be on pin 3, GPIO 3 on this particular one. And let's upload the code to it. I think that's all we need to do. Yep. Now, the stamp C3 obviously is the same controller that the Xiao module has in it. It's ESP-C3. And here we are. It seems that the socket on this thing is a little bit, the USB socket is a little bit dodgy. When I wiggle the plug, it sort of disconnects and connects. But anyway, if you look very carefully, you will probably see that on this one, there's a button underneath here. It says button, and it's G3. Remember, we put it on 3. There is an LED under there as well, which we're not actually using. We're using the module outside. So if I put it here, and I actually push that button, it works just the same. So that is that. So we've demonstrated that we can actually use different modules and so on with these Grove modules with different microcontrollers and what have you. And just to prove that there's nothing magic about these little Grove modules, here I have one of these ultra cheap Chinese ESP32 Room 32U modules. U means that it has an external antenna, which actually came with it, and we might use that. We try to do some Wi-Fi with it or something. But in any case, all I've done is I made up a little cable with some female or some male rather DuPont pins on it, and of course I plugged it into a little header board here, because these things actually are not breadboard friendly. They are too wide. So I made up a little board for it quite a while ago that it plugs into, and it's being powered by my bench power supply. And I just got like a little blink sketch going in there, and all I've done is I got ground, I have 5 volts, and I connected it up to pin 32 and 33. And of course this module here is only using one signal line there, the white one that's going to pin 33, and that's all it is. And if I wanted to use I2C, I can just use both pins 32 and 33 for some of the other modules that have 4 connections. So just to prove, that there's nothing magic, as I said, about these little Grove connectors. They just it's HY 2.0 pins, sockets, and you can buy those sort of on AliExpress, and you can make up your own little cables. And that's what I did. Okay, so that's as far as we're going to go with this initial introductory episode. We're going to be doing more interesting things, and we're going to take some of the code that's on the Seed Studio website, which invariably needs modification because it's kind of older, and it was written for the original Xiao SAMD module, and we're going to be using the C3 and S3 modules and so on, and make it work. In any case, don't forget to like and subscribe, and if you subscribe, you will get notified when the new episodes come out, and I'll see you guys later.